Apple, I'm going to be presenting this session. Did some of you see me already present yesterday? So, okay, all right. So, you know, I live, eat, and breathe this stuff. I absolutely love it. And yesterday in both sessions, I was mentioning that Wireshark 1.6 was going to be released yesterday, and it did get released yesterday, very late in the day, though. So if you go to wireshark.org/download, it'll take you to this page, and on this list right here, you'll see the stable release is listed, 1.4.6. And then we have the development release, which is 1.6. Now, this is the one that will become the next stable release. So we're right now on 1.6.0 release candidate number 1. Now, I'm on a 64-bit version of Windows here. I typically use the 32-bit version in working with Wireshark, just because the 64-bit version has been missing some functionality in the past. But I'm going to go ahead and grab that particular version. We'll go ahead and pull the release candidate version down. And for the session, I'll either use the release candidate if it seems to be doing pretty well, because not only does Wireshark get revved, but T-Shark gets revved, and Edit Cap gets revved, and Merge Cap gets revved. All the other tools also get revved at the same time. Excuse me. So I might as well see what this new version is going to look like. So it's going to go through and do the install in the background, and while it's doing that install, I can either show you the install process. Let me get over to it. Actually, I'll go ahead and show you the install process, because on my machine, I already have 1.4.6 loaded, I have 1.5.1 loaded, and now I want to install 1.6.0 release candidate 1 at the same time. So usually when it's kind of in the middle of releases like that, I'll have multiple copies of Wireshark running, multiple copies of T-Shark running on my system, multiple copies of all of the command line tools. So this is what happens, though. It's a little funky. Basically, it knows that I have 1.4.6 installed on my system, and it doesn't detect 1.5.1 because it's not in the default directory. I've got 1.4.6, the stable release, in the default Wireshark program file directory. So it tells me that it's already installed. Do I want to uninstall it first? And I do not want to uninstall it first. I'm going to go ahead and install 1.6 into a different directory, and I'm going to name it. And let me toggle over. Come on. There we go. So I'm just going to name it differently so it'll put it into a different directory. Now, the problem with running multiple revs of Wireshark simultaneously is that Wireshark only pulls the configuration preferences and all of your profiles and everything from the primary directory. So if I have my 1.4.6 in my just Wireshark directory, then I have 1.5.1 over here, 1.6.0 over here, all the profiles that I work with in 1.6 or 1.6 over here, they're all pulled from the main directory. So when we make changes to the configuration in 1.6, things that we don't have available in 1.5 or 1.4.6, it's kind of weird when you rev backwards, because it tries to understand, what is that preference setting? I don't understand anything like that. So you can get some errors when you go backwards if you start using some of the new preferences. So I'll go ahead and say that I do want to install this. I agree. Yes, blah, blah, blah. Yeah, whatever. And then when it gets to the directory, asking me for the directory, I just name it Wireshark 160RC1, which is release candidate 1. And I do not need to install a new version of WinPCAP because I'm on the current version. Now, in this class, we'll talk a little bit about WinPCAP, because a lot of people have no idea, but Wireshark for Windows already has a remote capture piece built into it. And it's built into WinPCAP. When you install WinPCAP, there's a little piece called RPCAPD, or Remote Packet Capture Daemon. And it's already sitting on your systems if you have installed Wireshark on a Windows host. So if I want to capture traffic, I'm sitting on my Wireshark machine, and let's say Brenda in my office is having problems. If I want to capture traffic at her workstation, I just need to make sure on her workstation that RPCAPD is running in the background, and that's it. I don't have to load up all the Wireshark, graphical interface. I don't have to run T-Shark. I don't have to run anything. Just in her WinPCAP directory, I just need to run that one tool. I don't even have to have Wireshark installed. I can just go out to the WinPCAP website, go grab WinPCAP, and put RPCAPD on her system. And then in Wireshark, I'll show you how I select that I want to go to a remote device to do the capture. And I'll show you some of the options. So basically, I'm not going to install WinPCAP. So now it's going through and doing the brand new install of 1.6.0. This should be a really stable release because the 1.5 series of development we didn't come up with a lot of huge problems like we did in the 1.3 days. 1.3 had a lot of issues in it. But when we get to command line capture today, there is one bug that just kills us. And there has been a lot of push on the developers to get this bug fixed. So it's bug number 2234, and you'll see it on my screens, and I've got it in the slides to tell you what happens. You may read a ton of things about what T-Shark can do with this one command parameter, but when you get down to it and you start using it, all of a sudden it doesn't do what you expect. It's a bug that you've hit. It's nothing wrong with the way you've done your command sequence. So I'll make sure I show you that bug so you're comfortable with it. So it prompts me, do I want to run Wireshark 1.6.0, the 64-bit? Now, in the background, you see that I have a version of Wireshark running. It has development version across the logo there. And it says on the top there that it's 1.5.1. So I'm already running one version of Wireshark, and I'm simultaneously going to run a second version on top of it. So here's 1.6. Let's see if it's up in the background. Yes, it is. So I just toggled to it. It's really hard to tell when you have different versions. One of the options when you're running Wireshark is to show the version information. Now, in the previous versions, 1.4.6 that you may have been using, you could only show the version information right here where you have the title of the page listed. But now with 1.6, we can have it up in the title, or up in the menu bar also. So up in that title bar at the very top. So it makes it a little bit easier because I never work with the start page open. I never work with the start page open. I live in the world of just the icon toolbar, so I never see the version information showing up. So Gerald added that up to the title bar so that we could see that. All right, let's see. We're going to go through some stuff. Instead of, well, I can tell you there are very few changes that happen in T-Shark in this rev. If you're in the 1.4.6 world, don't feel like you have to go run and get 1.6.0 version of T-Shark. Minor little changes, typos, little things like that came up with T-Shark. So I'm going to be running the stable version of T-Shark in here for you, so you can see exactly where it is. Also, there are times when we want to back rev to earlier versions of T-Shark. And that's to get rid of that bug problem that we hit. It wasn't in an earlier version, so we can go back in time to earlier sets of Wireshark, and we don't see those problems. So let me go back over the slide set, and then we'll pop over to Wireshark. You know, I'd rather spend all my time just playing with Wireshark and T-Shark. It's a lot more fun than slides, I'll tell you. Okay, you probably know that I'm the founder of Wireshark University and Chapel University. And yesterday we announced the LoRa's Lab Kit version 10. And I know that at 6 o'clock, all these people ran down to the Global Knowledge booth to go get them, and they went through 800 of them in about 25 minutes. So it was just crazy. Ah, you got yours. And then all of a sudden, they found another set that they had underneath the counter, and Brenda found a box of lab kits this morning. Where's Brenda? There she is right there. So how many of you did not get the lab kits? See, a lot of them. Brenda? Yes, yes, come up now. Come on. This is Brenda, yay. Thanks for finding those. So Brenda's worked with me for 11 years. I don't know if you know that, poor thing. If you ever are interested in anything like on-site training or anything like that, Brenda, just hand a stack to a group and have them pass it down. You don't have to. They're really good about this. Please don't take any extras because we want to make sure that we give them all back to people that are going out to the booth and things like that. And the ISO image for the lab kit, I'll make sure that it's online on Thursday when I get back to the office. I'm going to make an ISO image, put it up online at Wireshark U and at Chapel U. Okay? All right. So there's the information about the lab kit. Whatever extras we don't go through in here, we'll have down at the Global Knowledge booth. So if you know somebody and they didn't get one, you know, just send them down to the Global Knowledge booth and we'll drop that off. It'll take us about 45 minutes to walk over there, though. Unbelievable. I had no idea how big this place was. Okay. All right. So some of the things you're going to see on the lab kit you can use with T-Shark. There's a whole trace file repository on the lab kit, and there are some new trace files that I've placed in there. There's also a PDF that explains what's interesting about the trace files. Now, when we talk about remote capture and we talk about T-Shark, most people think that T-Shark can only be used for live capture, but that's not true. We can run T-Shark against an existing trace file to pull statistics out of that trace file or to make a subset of that trace file. So maybe I'm interested in taking just this one trace file that's got a bad HTTP session, and I want to pull just the packets that match the TCP analysis flags filter. I can run T-Shark against the existing trace file and make another trace file out of it that just has my problem packets in it. Or I can run T-Shark against it and say, I want to find all the protocol statistics for that trace. There's so many things you can do with T-Shark. It's much more functional than just live capture on the network. Okay, so why do we use command line capture? First of all, why do people even go to the command line capture? Because we know that in Wireshark we can say, okay, we want to capture and this is what we're interested in, and we can use capture filters and all these things. But the big thing is that there are times when your system will not keep up with the traffic when you're running the graphical interface. So if you're ever capturing in Wireshark, and let me go ahead and start a capture, and we'll see how Wireshark keeps up. So when you're running a capture in Wireshark, down on the bottom of the window, you'll see the status bar. And in the middle of the status bar, you're going to watch that as I start capturing. Now, I have two air PCAP adapters. There's a wired network here. There's also wireless, and we might as well capture live here. So don't surf porn. All right, so I just plugged in the two air PCAP adapters into my system. First thing I'm going to take a look at is how is Wireshark 1.6 on auto-recognizing my adapters. Not so hot yet. Okay. That has always been an issue, especially in the 64-bit version, in auto-recognizing when you add the air PCAP adapters. So I'll go ahead and I'll just restart that version. We can see 1.5 development version was messy on that too. Now to restart it, I didn't put my icons that I have here on the launch bar. That one is for the stable version, 1.4.6. This one is the development version. And I didn't put in a location or anything like that for the 1.6.0 version. So for me to launch it, until I pop it up there, I'm going to have to go out and launch it at the command line. So I'm going to have to go into my program files directory. So here's the way my program files look. My 1.4.6 and my 1.5.1 versions are going to sit in my program files x86 directory because they're the 32-bit versions. But this particular one that I just set up is going to sit in my, excuse me, my voice is getting raspier and raspier every day. But this one right here is going to be sitting in my, just my regular program files directory because it's a 64-bit version of Wireshark on a 64-bit machine. So I'm going to go into this directory, and these are all the command line tools. I'm going to sort this based on type. Here are all the command line tools, and you'll see Wireshark.exe listed in here. And a lot of you may not be familiar with the fact that there are 3 command line capture tools for Wireshark. Okay, if I look at this list, you'll see, excuse me, gosh, we have dump cap. Hang on. Gosh, sorry. We have dump cap, which is a command line tool. We have T-Shark, which is a command line tool. And we also have something called RawShark, which is a command line tool. And good luck getting a lot of details about RawShark on what it is, when did it go in, why did it go in there. RawShark is a command line tool, and with any of the command line tools, you can type them out at the command prompt with a dash and then lowercase h to find out a little bit about them. But RawShark is a little bit mysterious. Now, RawShark got snuck into Wireshark in version 1.3, the development series of 1.3. Gerald put it in there, and RawShark is actually the command line capture tool used with Pilot. Pilot is the graphical interface add-on product that goes on top of Wireshark. So if you're not familiar with Pilot and what happened recently, Wireshark, the trademark, and Case Technologies, where Gerald works, Gerald, who created Wireshark, and Loris created WinPCAP. Their company, Case Technologies, was bought by Riverbed. So Riverbed owns the trademark for Wireshark, and they own the Pilot product. Well, Pilot has this command line capture tool called RawShark. And since Gerald and Loris had been working on command line capture with RawShark, and it was a utility, they thought, well, let's just throw it into the Wireshark distribution chain. So they threw it in there, and the developers were like, what is that? Well, since Loris and Gerald threw it in there, we'll just leave it, but I don't know anybody that's going to use it. And really, you will never use RawShark. You will never use RawShark. It doesn't have the capability that DumpCap has. It doesn't have the capability that T-Shark has. So if you see it, don't feel like you have to use that at all. So I'm just going to do my capture here. On the left-hand side, look at this. It doesn't recognize my air PCAP adapters have been connected onto my system, even though I've connected them in and I've restarted Wireshark. Okay, release candidate version 1's got a problem. Okay, now, I will tell you that the first thing I would do when I'm working with release candidate, and I'm working in this environment, and this is why it's important to do it live at conferences, because otherwise I'll get a bunch of emails from people saying, hey, I went out to the release candidate and it just really stunk and I kept crashing it. This is what happens with the 64-bit version. It is always less stable than the 32-bit version. So if you're hitting some of these issues with the 64-bit version, I would highly recommend you go and grab the 32-bit version. I'll go ahead and say I'll close the program, that's fine. And I still want to work with a 64-bit version, but I'm going to attach different air PCAP adapters to it. I'm going to see if the driver is more stable with the air PCAP 802.11n adapters. And that's what my big spaghetti mess is here. So these are the 802.11n adapters. Those adapters I was plugging in, they're not... Ooh, that was close. That was pretty fast. You got that phone. All right, so, there we go. Good Lord. There's got to be a way to wrap these up that's better than what I do. Okay, so this one right here, this is the 802.11n adapter, and it's got the two antennas that hang off of it. I'll go ahead and plug it in. The adapter light goes green, indicating it's recognized and things like that. And I'll pop up my antennas here. And I just want to test how the release candidate is going to do on this. Because when I go out to T-Shark, I want to capture wireless traffic with T-Shark. So I've got to make sure that my system recognizes those adapters. So we'll go ahead, and I'm just going to restart Wireshark number 6 again. Okay, so it's having a problem. It's not seeing the air PCAP adapters. Now, I will say I was looking at the 1.5 version, and it was having some issues as well. With what's going on and recognizing those adapters. So it's kind of a funky thing. I'm going to close down. Let me see. I don't have that one running. Okay. I'm just going to close down and restart one more time, give it one more time to try to recognize the adapters. And it's not recognizing it. All right, on the left-hand side of my system, there's something called the air PCAP control panel. Now, if you're going to get air PCAP adapters and you're going to capture on wireless traffic, you'll want to go into the air PCAP control panel. And in the control panel, that's where you can do things like you can blink the LED to see, is it being recognized? So it's actually blinking my little LED here. So I know that the adapter is recognized, the driver is working. If there's any problem, it's a relationship between Wireshark and that adapter. And you may find that, especially in the 64-bit version. If Wireshark can't see your adapter, if T-Shark can't see your adapter, then you can't capture on it. So we know that Wireshark itself, the graphical interface, has got a problem. I'm going to go out to T-Shark in a moment. We'll see if T-Shark also has a problem. Okay, so let's go back to the slides and let me get some of those just passed through. Oh, this is what I want to show you, sorry. Let me go ahead and I'll plug in the wired cable. There it is. So at least we can have some traffic to test here. Okay. So why do we go to command line interface? It's typically because we can't keep up with the traffic rates. So I just went ahead and connected in my wired connector right here. And I'm going to go up in the upper left-hand corner. I don't like working in the start page at all. So get away from the idea of, so there's my air PCAP notification that says there's a problem. Well, that has to do with really Wireshark. So up here in the upper left-hand corner, the very first icon is the great icon that will show you the adapters. Yeah, okay. I think I'm done with 1.6.0 today. All right, we're going to go back out to 1.5.1, pull that up and see how it's doing. All right, there we go. Okay, now you notice I pulled up 1.5.1, and in the left-hand corner, it recognizes my air PCAP adapters. Now again, release candidate 1.6.0 just came out last night. I went and jumped into the 64-bit version, which in the real world, I typically would go grab the 32-bit version and work on that first. If you start working with release candidate and you're seeing all sorts of funky stuff, move to that 32-bit version. There's always strange things that happen with 64-bit. The only time I run the 64-bit version is when I'm not live capturing. I'm pulling an existing trace file and I want to analyze it. But when I'm doing live capture, I stay away from the 64-bit version. There are just some issues there. Some of that has to do with GTK, which is the graphical toolkit that Wireshark uses. So anyway, all right, so we can see that we recognize the adapter over here. If I am working with Wireshark, and let me pull this screen up a little bit so you can see it. I'm going to pull this window up. And I'm going to get out of this previous version. You'll notice, look what happened to that previous version, the 1.6. Down here in the middle of the status bar, as I start capturing, I'm going to pay attention to that status bar to see whether I have to go to command line capture or not. I'll just say that I want to go ahead and capture on the air PCAP adapter. So it's now going through and doing the capture. Watch this display area in the bottom. In the status bar, you have packets, which shows you how many packets that I'm currently capturing. Displayed shows how many are displayed, and I have no display filter, so it's showing me everything that it's capturing. Then you have something called marked. We can right mouse click on a packet and mark it, and then we can move from marked packet to marked packet to marked packet. And I don't have any packets marked. But right after that, if you ever see the word dropped show up, even if it says dropped 0, stop. You are losing packets. Even if it says dropped 0, Wireshark has detected that it has dropped some packets. It may not have an accurate count there as to how many it's dropped. But anytime you see it, you know you're not seeing the full view of the communications. And the minute that word shows up, you stop and you say, okay, I'm now going to go to command line capture. So that's the number one reason why people go to command line capture, is because in Wireshark, it's not able to keep up. They're on, really high usage network. So I'll go ahead and stop this capture. And from this point on, we'll have to go out to command line to capture all of our traffic. Why would Wireshark not keep up? Typically, your system doesn't have the resources required. Your card is not fast enough to pick up the packets. You're on a heavily utilized network, and Wireshark doesn't have the processing power to pull things up. Or you start adding too many columns and coloring rules like I do. You add a bunch of stuff to Wireshark and you overload it. Wireshark can't keep up, so it gets slower. Right? The other thing is it's easy to distribute the command line tools. So if I want to go to somebody else's workstation and I want to go ahead and run T-Shark, I don't have to have Wireshark installed. I can have T-Shark and WinPCAP installed. So I can just do the command line capture. Okay, T-Shark versus DumpCap. There are two command line tools that are built into Wireshark, and the difference between the two tools has to do with functionality and how much overhead they require. If you just ran DumpCap at the command line, the memory requirement is very, very low, 2,824K. And that's during an active capture, when it's actually running and capturing things. T-Shark itself is 2.6K. But just so you know, T-Shark uses DumpCap to do the capturing. T-Shark actually does not have the capability of capturing any packets. If you looked at the processes running on your machine when you're running T-Shark, you will always see DumpCap listed there as well, because DumpCap is actually the only tool that does the actual capture. Yet we run T-Shark when we think we're doing command line capture. T-Shark just adds more functionality, what we can find out about the packets as they're running. I'm sorry, T-Shark when it's running, we've got DumpCap running and then T-Shark on top of it, which is 83. 2008. Okay, I mean, it's really not that bad. It's a lot smaller than running Wireshark, especially when you start adding to Wireshark. All right, so at this point, I'm going to go out to command line. And I'm going to start running some of the tools here, or I'm going to run primarily T-Shark here. First thing I'd recommend, make sure that you put the Wireshark program file directory in your path. You don't want to be typing in the big long line to get to the tshark.exe file. So we put it in our path. You'll see on my system what I have in my path when I move over to my system. You'll want to run this from a traces directory. Create a directory called traces and run tshark from within that directory. Now, the rest of the slides that I have for you, we're going to not go through the slides anymore. Well, maybe I'll just pop over every once in a while to tell you some of the things you can do. But the top parameters that you need to understand about tshark are going to be to run tshark-h, lowercase h, to see what the command parameters are, and tshark-capital D. Now, capital D will list the interfaces available to you. And they're not always listed in the same order that they're in Wireshark. So you can't just assume that the list, that air PCAP adapter will be the first on the list, just like I had in Wireshark. So I've got to look at what my interface listing is on the system. And then I have to tell tshark when I capture which interface I want to capture on. When Wireshark defaults to an interface, it defaults to the first interface on the list, but you won't know what that is always, because the list is different in Wireshark versus tshark. So we always put in a dash lowercase I. All right, so I'm going to go pop over to my system, and let's take a look at what tshark says excuse me, about the interfaces available. Oops, I don't know what I just hit to start there. I think another iteration of Wireshark. All right, so on my system, I'm going to, hang on, let me close that one. There's the nice stable release version, and away it goes. Okay, so I'm going to go on my system, I'm going to go to my, I think I have a traces directory. Now, traces, let me do a dir here and see. Yeah, there's nothing interesting there. I'm going to make a directory, and I'm going to make it, and I'm going to call it TechEd tshark. All right, so now I'm in this directory, and if I just type in path to see what my path is, you'll see on this system, somewhere in that path list, there it is, there is my path for Wireshark sitting in there. And that's the version of tshark it's going to be running. It's going to be running the stable version of tshark right now. That's the 1.4.6 version of tshark. So because I just have that in my path, I can go ahead and type tshark dash interface whatever and start capturing the traffic. The first thing I'm going to do is tshark-h, and that will list not only the version of tshark that I'm running at the top, but it will also give me all of the command parameters that are available to me in tshark. There is a case sensitivity in the parameter, so watch out. A lowercase r is not the same as a capital letter R. So the things you have to understand are tshark-h, tshark-capital D, and then tshark lowercase I. Lowercase I is how we'll define which interface we want. So now that I see the help screen, I can see what version of tshark I'm working on here. I'm going to do a tshark dash and then a capital D. So these are the three interfaces that tshark recognizes. And I'm connected to the wired network, but I'm also connected to the wireless network. So I'll probably do more capture on the wireless because it's more interesting, I think, what's going on. All right, next set of command parameters that we're going to work with as we do this capture. There we go. All right. Okay, so we know that dash lowercase I will be used to define the interface that we want to capture on. Now, dash lowercase f allows us to define a capture filter. And I would recommend that you get used to the idea of putting your capture filters in quotes. And when we talk about capture filters, right now, you can't use the capture filter name. You have to use the capture filter string. So if you've created a capture filter that is all traffic from port 2327, let's say, and you gave that capture filter a name in Wireshark called all traffic from port 2327, and the string down below it is just port 2327. You have to put the string, the capture filter string in there. tshark at command line will not recognize the capture filter names, and it will not recognize the display filter names. A lot of people have asked for that, because I don't want to type in the big long string. I want my simple little name, problem packets. I don't want to type in that big long thing, but right now you do have to type in the full capture string. So it's dash lowercase f, and then in quotes, port space 2627, unquote. Dash W is how we save to a file. Now, if you don't put in a dash W, these packets are going to be showing on your screen. By default, the standard output is to show all the packets that it's seeing on the screen. It will not show you every piece of every packet. It will give you a summary of all these packets. And if you're on a really, really busy network, you're going to have these packets flying by on the screen, and there's not a lot you can do probably when it's flying by. You know, it looks very impressive if your boss is walking up behind you, I guess. You just, look at this. Oh, look at that, look at that. And it's just, zoom, thousands of packets going by. All right, so I'm going to go out to command line now, and I'm going to start doing some capture, but I'm going to capture out to the screen in this case. So the first thing I'm going to, oops, whoa, wrong keys. All right. So T-Shark, okay, so I did my, I did my T-Shark dash capital D, and for me, the air PCAP adapter is the very first adapter there. So when I'm ready to capture, I'm going to do a T-Shark dash I1. You don't have to have a space after the letter I. You can put the one right next to it if you want to. And then I'm going to do a filter. And this is a capture filter that I'm going to put in here, and I'm interested in all traffic that's, I'll just say port, let's do port 67. That's going to show me any DNS traffic, or sorry, DHCP traffic that might be taking place on the wireless network. And if I want to write it to a file, I'm going to do the dash W. But right now, I don't want to. I want to go ahead and pop it to my screen. Now, there's a note on my system that came up at the very top, and it said, hey, I can't open this key file. When T-Shark is running, it's using the default preferences that I have set in my Wireshark directory. And in my default preferences, I have Wireshark set to decrypt SSL traffic using a certain key that's sitting in a directory. And T-Shark is pulling those Wireshark preferences. Even though it's not going to use a lot of those preferences, it's going ahead and pulling those preferences out, and I don't have that key sitting in that directory anymore. So it gives me a little note, but it's kind of nice to show people that, hey, we are still using our Wireshark preferences file. So right now, all I'm getting is I'm getting a list of all the DHCP traffic that's taking place on the wireless network. As to whether I can do anything with that, it depends on, you know, how interesting the traffic is. Now, one of the reasons why we write to a file is because T-Shark is notorious about not giving you control to stop the capture. You know how we do like Control X, Control Z? It's like, oh, get me out of here, stop, whatever you're running. Good luck with T-Shark. Okay, I can sit here and I can Control X and Control Z, try to break this. I do not even have control of this. T-Shark is just totally taking over. So you'll see that, and a lot of people get really angry about that and frustrated, but that's why we write things to a file. We rarely do analysis just pulling up from the screen. So when you hit this instance with T-Shark, where it just kind of takes over and runs, which happens all the time, everybody goes through this, you could just close the command prompt and open it back up again. Now, excuse me, all the traffic that we're seeing right here, none of it is being saved to disk. It's just gone. It's just, T-Shark is just showing me the traffic, the basics of the traffic, and that's it. And again, if you don't do that dash W, you might get stuck in that loop where T-Shark just keeps going and going and going and going. So I'm going to go back to my directory that I was in. Users, CD LoRa, CD, what do I call it, TechEd. There we go. Okay. So now what I'm going to do is I'm going to go through some of the other parameters, but I want to write to a file. I want to make sure that I do exactly what I was doing before, T-Shark-I1. And if you're not sure if it's the same interface, run your dash capital D, but it should be the same listing. Once you get your listing, it's typically the same each time you come into T-Shark. So I'm going to say that I want to capture on interface number 1, oops, and I'm going to apply a capture filter for port 67 traffic. And I'm going to write this to a file, and I'm going to call it port67.pcap. Now, if I hit enter here, it's going to sit there and keep capturing to that file. And if I want to stop it, I want to do a Control Z or a Control X to try to break out of that. I may or may not be successful. So because of that, I would recommend that you have some sort of a stop condition that you define, whether it's based on the amount of data or the number of packets, and I'll go through the capabilities there. But I'm going to go ahead and write this to a file. Oops, I already have right to a file. But I'm going to say that I want to capture 100 packets. So a lowercase c is how we say how many packets we want to capture too. And don't worry, you don't have to write this down. It's all in slide sets that you can grab. So there's my note about the directory. It's looking for that key because it's using my default Wireshark preferences. I don't have that key sitting in there. All it did was it just showed me I've got 100 packets. That's it. Look in the directory, and there's my port 67.pcap file. There should be 100 packets in that file. Now, what I do is I typically capture in T-Shark, analyze in Wireshark. There's a lot of information I can learn in T-Shark going through statistics, but I don't want to do that. I want to do all my work inside of Wireshark once I get T-Shark set up. We'll talk in a moment about what happens if you capture too much in T-Shark. People go crazy, and they run T-Shark and then go to lunch. And then they come back, and they've written to this massive file. So we've got to watch out for that. Excuse me. In the handouts, when you get the PowerPoints for this, for every one of the command set screens in PowerPoint, I gave you some examples of how you might use the command line. And in this particular example, I put in a dash and a capital S in there. Now, the dash capital S means that while you are writing to a file, I want you to show me the packets on the screen at the same time. The dash S means show me the packets. Instead of like before, it just counted up to 100. That's all I could see. If you're interested in knowing, what the packets look like, just use the dash capital S, and those will all show up. So in all of the instances here, there are sample command parameters for you to run. Now, as far as, sorry. Oh, man. Uh-oh. All right, as far as stop conditions, you saw me use the dash C, which is a packet count. So if I want to only capture 100 packets, then I put in a dash C 100 like I did a minute ago. Dash A is another way to do auto stop conditions. So we say dash A, and then we can say, excuse me, a duration, stop after how many seconds. It's not hours, it's not minutes. People have been asking for that. But it's, I want to capture for 10 seconds. I want to capture for 60 seconds. I want to capture for 120 seconds. We just do a dash A, and then we put in the word duration, colon, and then 120 if we want that. Or the file size, and the file size is defined in kilobytes, not in megabytes, which is such a hassle. Okay. Not in gigs, but hopefully you're not picking up gigs of traffic. Wireshark will not be able to process gigs of traffic. And then you can say how many files you want it to stop after. So we can say that we want to stop after 6 files or something like that. Besides having these auto stop conditions where you can say, I want to stop after this amount of time has passed up, we also have a ring buffer capability. And I'll show you the screens on ring buffer, but when you get the slide, you'll see I have an example here of just using the dash C for 100 packets with the dash S to view it. Very, very simple, very easy to do. And I'll show you some auto stop. Remember that the dash S is to show it during the capture. So here's the ring buffer. So in a moment, we'll start using the ring buffer and auto stop conditions. You do a dash B, and the ring buffer allows me to ensure that I'm not going to fill up my whole entire hard drive. Gosh, I don't want to fill up my whole entire hard drive as I'm capturing traffic. I can say in T-Shark, I want to capture a number of 10 meg files, but I only want to save the last 10 that I've captured. And we do that with a ring buffer. Ring buffer is first in, first out. So we can say, I want to use a ring buffer, and this is when I want to go to the next file. I want to go to the next file after 10 seconds. Or I want to build the next file after I've caught 1 meg. Or I want to, and I have to put it in kilobytes. Or I want to go to the next file, whatever. And here we define how many files we want to keep on our system. So I'm going to run capture with T-Shark, and we're going to run a ring buffer, and we're going to put in an auto stop condition as well for this. So we're going to combine the auto stop, we're going to combine the auto stop, the last one, with the ring buffer. And here's an example of using a ring buffer. So we're running T-Shark. I have a dash B file size colon 1000. So that means that it's going to automatically capture a 1,000 kilobyte file. it's going to keep capturing these files, 1,000 kilobytes, but it's only going to show me and save the last two 1,000 kilobyte files. So if I've got a bigger file size, I won't fill up my whole entire hard drive. And the files will be saved starting with the name traces-test. Now that's going to keep running. I don't have an auto stop condition defined. It's going to just keep running in the background, pulling these 1,000 kilobyte files, and it'll have file number 1, file number 2, and then it'll start working on file number 3. It'll delete file number 1, and I'll have file number 2 and 3. Then it will delete number 2, and then I'll have 3 and 4. And it'll delete number 3, and I'll have 4 and 5. And it will just keep going. So why would you ever use something like that? Servers. Servers that have problems at whatever time in the middle of the night, we can set up Wireshark to run using this ring buffer, and we can say that we want you to capture 5 minutes worth of traffic to and from the server in the middle of the night. And I want you to just keep saving these files. And I will have this ring buffer file setting really, really large, so I know that I will have all of these 5-minute segments from 6 o'clock at night all the way until 8 o'clock in the morning. I know that I'll be able to capture all of these things. If anything happened in the middle of the night with that server, all the files that I have a date and time stamp on them. And I can go directly to the trace file of what happened to that server in the communications area, what happened at 4:06 a.m., what was the traffic to and from that server. So every one of these files is going to be time-stamped for us. So when you see me running this command parameter, doing file size colon whatever I'm going to do, and the B files, I'm also going to put in my auto stop. So to do the auto stop, I'm going to go back to the last slide, and I'm going to use that -A parameter. So I'm going to hop over to my system here, and let me get my little notes here. All right. So I'm going to pop over to this system, my Wireshark system, and all right. Again, we're working in the stable version. I'm going to mention in a moment what the bug is that's going to cause some problems in just a second here. Okay, so the first thing I'm going to do, I'm going to say that I want to do T-Shark, I want to capture off of the first interface. Now I want to do a ring buffer, so I'm going to do B file size. And let's say, we'll go ahead and do just 1,000 kilobytes. I'm going to do a ring buffer of, let's say, 4 files. Files colon 4. And then I'm going to do an auto stop condition. And that's where we're going to put in how many files we want it to save. Sorry, not how many files we want to save. How many files we want it to go ahead and capture. It's only going to save the last 4 because I've set a ring buffer for that. But I'll let it run for 7 files, let's say. So I'm going to use the -A auto stop and files again. So it looks really weird because you're using 2 different conditions here. But I'm going to do, let me show you the one I'm going to do. I'm going to do the -A files and 7. So 2 places I'm going to have files in here. Let me make sure. Files, colon 7. Now, you got to tell it what files to write to. So -W is going to be my naming of the files, and I'm going to call it ringset1.pcap. All right. So when you get this, T-Shark, invalid capture filter KB, you'll notice that in the file size, whenever you make a mistake in the typing area, when you're sitting inside of Wireshark and you do any captures, we've got filtering, the display filter's got a red background, green background, yellow background. We've got all these ways of telling you that there's a problem. But this is just like if you make a mistake in a capture filter. And you'll notice that if Wireshark sees you throw something up there that doesn't belong, it always thinks it's something weird with the capture filter syntax. Everything reads as capture filter syntax. Even if you hit a bug in T-Shark, it'll come up and tell you there's a problem with the capture filter syntax, and it's not, it's a bug. And I'm going to bring one of those up for you. I'm going to show you exactly what it looks like. So we're just going to pop in and get rid of the KB thing. You don't define anything about that, but in the future you will. So one of the things being changed in T-Shark is the ability of putting in 1,000 MB for megabytes. 10 MB. Right now we can't put in any delimiter after the size number. It's just stuck. You have to just do it all in kilobytes. So we'll go ahead and just run this one. Oop, I'm going to go backwards 3. There we go. And hit enter. All right, so how would I have seen the packets on the screen at the same time? That's right. -S would have shown me what I was capturing. It showed me that information on the screen. So this is just now running in the background. It's going to get just a series of, it's going to go 7 1,000 byte files, but it's going to recycle them. So when I finish, I'll only find the last 4 sitting on my system. So it's going to be just running in the background, and I'm going to pop over to the slides while that just goes ahead and runs. And when it's all done, it'll just dump me at command line. And that's it. Now, for those of you that are scripting wizards and those of you that love batch files, there's no reason why you can't take T-Shark and all these different styles of parameters that you use and build them just into batch files with variables. So maybe I always run this command line, but I change the file name. I'll put that as a variable 1. And then at command line, when I'm running that batch file, I'll just go ahead and put in whatever the file name is I want to use for that particular instance. The more you run T-Shark, the more you get tired of running these long lines on them. Start building batch files on those things and put variables in. We can see that this one is done, so I'll go ahead and look at the directory. There are my files. Okay. Now you'll notice one thing. What did I say about ring buffer? I said I only wanted the last 4 files, didn't I? But it's showing me that it captured all 7 files. Okay. The ring buffer on 1.4.6 has a bug in it. Okay. That's why we want to move to 1.6. That was like the only big fix that was done with T-Shark was the ring buffer. I'm going to show you another bug that's in 1.4.6. And it's the reason why a lot of people moved backwards in time in Wireshark and went to the 1.2 version of T-Shark when they were running it. They went backwards in time because of this bug 2234. All right. So these are some of the things that you're going to have to watch. I'd rather show you, a lot of people think T-Shark's really great, but it has some limitations. But remember, with T-Shark, you can go back in time to the 1.2 versions of T-Shark. 1.6 version of T-Shark, you can go and see how does 1.6 look in running it. Do we have all these fixes patched? And 1.6 came out just last night, so I haven't run through all the parameters with T-Shark to see which ones are now working, which ones are not. And all I do is I just run my batch files against it and just let it run with the batch files and see when it barfs and tells me, no, I don't do that, no, or when it captures too much when I tell it to capture things. Okay? All right, so I'm going to pop back over the slides. I'm going to show you some of the other things. So watch out for that one with this version. And again, 1.6, that was one of the things they worked on. All right, we went through the ring buffer stuff, which, okay, kind of an issue there. All right, when you're running 1.6, the process that I just went through right there, I'm going to change the way I did it because I have to use ring buffers and I only have version 1.6 to work with. The command parameter that I just went through, let me pull it up on my system here. Let me pop over and do one more thing for you. Oh, let me go back. Hang on. You see how we have the auto stop with file size in there? This is what a lot of people do. They take the ring buffer file size, the -B file size, and they say, forget that, I'm not going to use that, I'm going to use a -A file size. Let me show you what happens when you use -A file size instead of -B. So I've got the command parameter here, and I'm going to go back and I'm going to change the file size. I'm going to use -A for an auto stop condition now. And I'm going to change this to ring set 2. And I'm going to hit enter. All right, so it's going to go through the capture process, but I want to show you what you end up with when you're finished. We know that it's going to take a bit for this to do this. So well, I'm just going to let it run in the background, and I'll pop over and I'll show you the next set of command parameters that we're going to run. And remember, the dash S will always show you everything that you're capturing. Just in that summary, though. You won't get all the details. All right, so here's an example of running the dash B parameter. This is what I was just showing you, the dash B parameter, where we've got that issue where it's not just saving the last two files, unfortunately. All right, so here, all right, this is where the bug is. This is the big, ugly bug that we would love to have fixed. When you use a dash R, it means that you're telling T-Shark to go ahead and open up an existing trace file. I might want to open up an existing trace file, put in a dash F, put in a capture filter value, and then write the new file to disk. And I can do that. That works great. This dash capital R, it's called a read filter, which is also a display filter. And I live in the world of display filters. I love display filters. I apply them all the time to my traffic. So what we would like, ideally, is to run T-Shark. And you'll see I have it saying I want to read a file called sip.pcap. I want to apply a display filter where my sip call ID field contains this value. And you'll notice I have double quotes here. I have quotes inside of quotes because in the actual display filter, I have to have quotes around the characters that contains uses. And then around the whole display filter line, I have to have quotes. Anytime you have a space in your display filter line, you've got to have quotes. And I want to write just those files to another trace file called sip calls. Okay. If I left out the dash R at the beginning, the dash lowercase r, and I tried to build a display filter on traffic as I'm capturing it live, we can't do that anymore. We used to be able to do that. We used to be able to run T-Shark and apply our very complex display filters to the traffic as it's being captured and only see the traffic we're interested in based on display filters. And we can't do that. And that's that bug that came up. This bug came up quite a while ago, and people are just pissed off about it. This is the bug number. It's 2234. So when you try to run the dash capital R and you didn't tell it that you're opening an existing file, T-Shark's going to barf on you. If you like that functionality, go back in revs. There are a lot of people that go back in revs in T-Shark to earlier versions. And you'll see it. If you ever go to Wireshark, ask.wireshark.org, which is the question answer form, you'll see tons of people talking about that bug right there. And it's still outstanding with 1.6. It's still outstanding. And you'll see there's a lot of reasons why that bug is out there. I'm going to pop over to my system really quickly. I want to show you what that last capture did. There, it's finished with the last capture. Oops. And you'll notice it's still caught all of those. Okay? So there are two big problems with T-Shark 1.4.6. One is the ring buffer has got an issue, the ring buffer setting. And the other is using display filters on a live capture. That's the reason we go backwards in time to earlier versions of Wireshark, the 1.2 versions, or sorry, T-Shark, the 1.2 versions. 1.6 has the ring buffer thing fixed, but not the capture with the display filter. That is not fixed yet. So all these things, unfortunately, you know, T-Shark's great at what it does, but it has these limitations in it, and we're somewhat at the mercy of the developers to get some of these things fixed. All right, here are things that I would never use, honestly, with T-Shark, but it's available. Some people do. Dash lowercase n is enabled by default, so you don't have to type this in. But it means that you don't want to do name resolution. You don't want to do any name resolution. You have the capability while you're capturing live to say, I want to do name resolution. I don't want to see an IP address. I want to see the host name that somebody's communicating with. So you can do a dash capital N, and then you define what name resolution you want. So you could do a dash capital N and say, I want M lowercase m for MAC name resolution. That will resolve the first 3 bytes of the hardware address. Dash t, or just lowercase t, that will do the transport. That means wherever Wireshark sees the number 80 in a port number, it'll put in the letters HTTP. Dash capital N lower n is death. Okay? If you do a dash capital N, meaning I'm enabling name resolution and I want network name resolution, what Wireshark will do is for T-Shark, every IP address it sees during the capture process, it will look in the Wireshark program file directory for a host file, and if it doesn't have it, it will then do inverse pointer queries to your DNS server. And because people are often capturing a lot of traffic with T-Shark, you're going to kill your DNS server. It's one of the great ways of making Wireshark an attack tool as opposed to an analysis tool. Okay? All right. Here's an example, but I want you to be careful of this. If you're going to run this particular example right here, I want you to back rev to the 1.2 version of T-Shark. I am running T-Shark against live traffic. I'm not doing a lowercase r, opening an existing trace file. I'm running against live traffic. We know bug 2234 has been plaguing us forever. So for me to run this and have this work properly, I want to go back rev it to the 1.2 version. So T-Shark -R means I'm applying a capture or a display filter. And this is the display filter. I don't want to see any ARP traffic. I don't want to see any boot P traffic. Okay, DHCP traffic is boot P traffic. DHCP is based on boot P. So if you wanted to see all DHCP, you put in boot P. If you don't want to see any DHCP, you put in exclamation point boot P. And there is my name definition there of what I want to do. I've got a -N, which I typically always have. I never use the name resolution stuff because it'll just kill the network. Now -T and -DD there. -T is for a time setting. DD is delta display. For those of you that saw me configure Wireshark yesterday, I always change my time column setting. Now that's only going to help me if I'm showing the packets on the screen. Then the time column will be set that way. If I'm not showing it on the screen, it really doesn't do me any good to see it listed. Now here are some interesting parameters, and I'm going to open the traffic up and I'm going to run it, and I'm going to pull some parameters. There are times when I only want to know what is the TCP window size field of all the packets that are happening right now in the background. What's everybody's window size field value? And I can tell T-Shark that I want it to display that information to me, and I want to save it into a comma-separated file. This is one of the great uses of T-Shark. So now what I'm going to do is I'm going to run T-Shark at the command line. I'm going to say that I want to see some fields. I'm going to pipe it to my screen, but I'm also going to save it to a file. -T fields is the first thing I'm going to type in. And then after that, I'm going to put in -E and I'm TCP.window_size. That's the field I want to see. So it's going to pipe that information to me. If you want to, you can have headers put on it and columns so that when you save it to a file, you can import it into Excel and have Excel chart and graph things. All right, so I'm going to pop open this one, and you'll see this really big, long example on the bottom. And that example that I've given you is what we would use to capture traffic off of interface number 1, apply a capture filter using traffic just from this source IP address, capture 100 packets. I'm interested in the IP source address field and the TCP destination port field and the TCP sequence number field. I want you to put in column headers, which say those are the 3 fields I'm interested in, and I want you to use a comma separator and export everything to a CSV file called tcpseq.csv. Like I said, batch files. People batch file things, script things out with T-Shark. So let's go ahead and run something, and I'll pull the window size field values, which is what I'm interested in the traffic running here. So T-Shark, oops, let me get over here. T-Shark-H. These parameters, they're all listed towards the bottom here. You'll see, this is the set I'm interested in right here, all of this. All right, so I'm going to go, oops, CLS, T-Shark. I'm going to do I3 again, I1 again, sorry. I'm going to be pulling the wireless traffic. I'm going to put in a capture filter of TCP. I only want to see the TCP traffic back there. And then I'm going to say T fields. I want to see the following fields. Then I'm going to list the fields I'm interested in. And I'm interested in, we'll do the TCP.window_size field. And I'm interested in maybe the IP header. Let's do the IP time to live field. Any other field? TCP port. Let's do, now we'll just do those two, and we'll pull it into a comma-separated format. All right, when you get into the formats, you'll see notes if you look at the help screen in Wireshark, some stuff about the formats. So let me show you. Okay, you've got header in there. So all you have to do is you have to do just dash capital E, and then you do header equals yes if you want the header. There's the example down there. Okay, separator. You can do comma separation, you can do tab separation, you can do space separation, and you'll see the definition. If I do a /T, it's going to be tab separated. If it's going to do /S, it's going to be space separated. You can put any character you want in there to separate it, anything at all. Okay, occurrence. Occurrence freaks people out. The definition is you print the first, last, or all occurrences of each field. Well, when would you have more than one occurrence of an IP time to live field? Do you know of any packets where you would have more than one IP time to live field in a single packet? That's right, ICMP packets, exactly. So an ICMP destination reachable packet gets sent to you, and you will get the original IP header and the original at least 8 bytes that followed that IP header. So that's where we would use that occurrence thing. Most people don't use it. An aggregator is when you're combining all of the information in there. You don't want it tab separated or anything like that. You just want it to put all of this information, and it just wraps the whole entire thing. It doesn't do nice columns, and we don't really like that. Okay, so I'm going to pop over, and I'm going to do e-header on mine. I'm going to put in a header, and I'm going to do a separator on mine. It's going to be just like this one down here. That's the one I always use. So over on mine, I'm going to do e-header dash, oops, e header equals yes. And then I'm going to do a dash, what was I going to do? Separator. Yeah, separator equals, where's my equal sign? Comma. I'm going to capture 100 packets. I'm going to write them to a file called TCP win size.pcap. And I'm going to do a dash S on this one. Okay. So what it's showing me right now, there's my header right there, TCP window underscore size, comma, IP time to live. You saw it just was up there a moment ago. So it gave me the header, and I've just got the values, comma, separated in there. That's a pretty low time to live value, 49 on some of the traffic here, which is weird. Okay. You will find that if T-Shark captures and sees a handshake packet and window scaling is on in the handshake, T-Shark will show you the window scale value if you choose that field. When we go to 1.6, we have a new field name. It's the TCP calculated window size. So that's what we want to pipe up on the screen. All right, let me pop through just some of the last parameters and go through some of the remote capture stuff that we can do in here. So here we have extracting fields at command line. All I did was I extracted. I just wanted to show you how we pop it into Excel. Statistics. Most people don't use this because they know that Wireshark's capability of showing you statistics is far greater than T-Shark's. But you can, if you want to, you can export and say, look, I just want to know all the protocol hierarchy information. Now, the reference you see on the figure there has to do with the Wireshark Network Analysis book. There's a figure in the Wireshark Network Analysis book where you see I worked a bunch with statistics. And that's where you'll be able to see, okay, this is, you know, all the things that are possible with statistics. I put a lot of things out there, but honestly, this just pales by comparison to what you can find in Wireshark, where you can graph and do things. We capture in T-Shark, but we analyze in Wireshark. But yes, you can have it running and just counting up the number of, ARP packets for you, and it can do the protocol hierarchy in front of you. But why would you do it at command line when everything can be done inside of Wireshark for that? It's much better. So here's just a list of command line strings and options available with the command line strings. And I've got a number of slides. I also wanted to bring up ask.wireshark.org. I mentioned it just a little bit ago. Ask.wireshark.org is the question and answer forum for anybody using Wireshark. And if you come up with questions, you're hitting problems, or you wonder why you're seeing something on the network, you can go to ask.wireshark.org and you can pose your question out there. And you will see that I am out there answering questions. The core developers are out there answering questions. This is a question that came in from this guy, Steve, and it was answered by Saki Block, one of the key core developers for Wireshark. And you can see that in Saki's answer, he's got information about using Cygwin with T-Shark. Now, do any of you use Cygwin for stuff? Just a few of you? Okay. If you're familiar with going out and downloading Cygwin and setting it up on your system, you can run a Cygwin shell with T-Shark, and what you'll be able to do is and if you go out there to the ask.wireshark.org, just do a search for Cygwin, and you will see all these different options. What you can do is you can run T-Shark command line, and then you can sort the results, or you can search the results. That capability is not in T-Shark. T-Shark, you can't do that. But with a Cygwin shell, running in a Cygwin shell, you can. You can add all this functionality to T-Shark. And there are tons of people that do that, and Sake is really big. If you want to know all the phenomenal things you can do, the really advanced things with T-Shark, go do a search for Sake Block. And I'm going to type his name in here so you can search his name. You will see that there is a website where Sake has got a huge list of videos on how to do advanced parameters with T-Shark. So it's T-Shark Advanced Scripting. And Sake Block, this is how he spells his name. And the website that you'll see he's got these videos out on, you could just look up his name, but if you go to lovemytool.com, obviously a site put up by a guy, but anyway, if you go to that website, you're going to see a lot of protocol analysts are out there. Tony Fortunato, one of our Wireshark instructors, is out there. Saki Block is out there all the time, putting things. Mike Panaki is out there recording things about what they're doing with analysis. And in the area of command line capture, nobody beats what Sake has put together in command line capture for his scripting. But again, he runs everything inside of a Cygwin shell, or he's going to be running on a Linux box, where all this capability is native in Linux. So it may be one of the times where you might want to consider, if you want to do a lot of the advanced scripting, you may have to go out to a Linux box if you don't want to run the Cygwin shell stuff. But he's got great stuff there. Get on to ask.wireshark.org. Get on there, log in, create an account, start putting up some questions. Look through the questions that are there. It's like a whole training on the latest and greatest things that people are hitting. Now, as far as remote capture goes, you can do remote capture from inside of Wireshark. You don't have to tunnel to another machine and run T-Shark at command line if you don't want to. You don't have to remote control to another machine. It's actually built into Wireshark to do this. But the other machine has got to be running WinPCAP's rpcapd.exe file. So if I have 3 users on my network and I want to remotely capture from any of those 3 users, at the command line, I've got to go to their systems and I've got to run rpcapd.exe, that's the command line. And right now we don't have security built into it, so you need to be aware of that. Okay? So there's no security, so that means when they run rpcapd, there's a default port number that it'll run on, a listening port number. But anybody running Wireshark can go and do remote capture on their machines. So you need to be very careful that when it's running, it's only during the time when you're doing the captures. And then once you're finished with the captures, rpcapd is unloaded from their machine. There's the default port number, 2002, that it's going to come up with. So let me show you in Wireshark where we configure it to run remote capture. So I'm going to pop over to my machine. And over here inside of Wireshark, the second button on the icon toolbar will show you the Capture Options window. And a lot of people never even notice this Capture Options window, but in the upper left-hand corner, look what it says. It says local or, remote. So I'm going to choose to do a remote capture, and all I have to do is put in the IP address of the host that's running RPCAPD. If I don't want to, I don't even have to put in the port number, because if we're using the default port number, Wireshark will automatically put that in. Now below that, you're going to see null authentication or password authentication. Right now, Wireshark understands using password authentication, but RPCAPD does not. You have Gerald sitting here, Loris sitting here. Gerald created Wireshark, Loris created WinPCAP. Gerald's been really busy updating Wireshark and doing all these things with Wireshark. Loris has been working so much of the time on Pilot that RPCAPD didn't get all the extra things. RPCAPD is just a little bit behind where Wireshark is. Once we get the password authentication in, it's going to be great. And one of the nice things about the way Wireshark does the remote capture is that when RPCAPD is running on the remote machine, RPCAPD will not capture any of the traffic coming to the Wireshark host. So you will be able to capture all the traffic except the traffic that you're sending me so that I can listen in on your traffic. You won't get the remote connection, which is really nice. By default, it does that. You will not see it. Now, in the LoRa's Lab Kit, one of the trace files that I have shows you the RPCAPD connection setup routine. So you can see exactly what's required as far as opening firewall ports, what that traffic looks like, so you'll feel comfortable, okay, this is what it looks like. It looks like a whole new protocol on my network. And when you see that protocol on your network, don't freak out, as long as you're the one that's running Wireshark to capture and not somebody else. As you can imagine, throwing RPCAPD around a network is a very bad thing. If that gets started on a system, and anybody scans a target and sees port 2002 and says, oh, I wonder if they're running RPCAPD, they can just run Wireshark and grab all the traffic to and from that user. So we really kind of watch out, and we only run RPCAPD when we absolutely positively have got to run it. So there, in here, all I do is I put in the IP address of the target I want to go to, and for me, I'm done with it. And at that point, Wireshark starts capturing, and everything is the remote host. Now, if I type in an address right now, 10.1.1, or 1.1.1, and I say OK. When I start the capture, Wireshark's going to try to find that 10.1.1.1 host. And if it finds the 10.1.1.1 host, then it's hoping that port 2002 by default is open. If it's not, we'll get a reset from that target system and it won't work. So I'll go ahead and just hit start. Yeah, okay. Can't get a list of the interfaces. Is this server properly configured on 10.1.1.1? So that just simply means that either they're not running RPCAPD or they're running it on a different port than we're trying to get to. That's all you'll see in that area. But it's super simple to set up. It's one of those things you want to do in the lab, test it, get it ready, so whenever you need it, it's set. It's really nice. RPCAPD is going to be really nice coming up as it gets revised and it has the security piece built into it. Anybody capturing that traffic that's going back and forth, they're going to see a totally different protocol going between the two systems. It's not your regular protocols that sit on your network. It's all RPCAPD remote protocol traffic. Okay, so these are the only parameters available right now when you go to that remote system and you run RPCAPD. You will see a whole list of available parameters here. And there is an option in there to run in active mode. You can set up RPCAPD so that Wireshark will touch the RPCAPD machine, but it will actually make the connection back to Wireshark instead of Wireshark making the connection to it. So you can reverse the way the connection is run. Excuse me, the default is to run in active mode. Okay. You will see a reference here running in daemon mode for Unix only. There's an RPCAPD version to run on a Unix host as well now. So most people think of WinPCAP and RPCAP as being only Windows hosts or Windows products, but they aren't. There's no RPCAPD 64, No 64-bit version out there. It's only 32-bit version that's out there. And when you run rpcapd at the remote host and you put in your information about what you want to do and the port number you want to run on, all you have to do is after you run it, type in rpcapd-s and give it a file name, and it just saved the configuration that you used. The next time you run it, you just say rpcapd-f and you put in that name, and it will auto-load that configuration. Some companies, they go through and they make the configuration file and then they send it out to whoever's going to be running rpcapd, and then the batch file loads rpcapd with that configuration file. rpcapd has a long way to go to be where we want it to be. A long way to go. The security thing is big with rpcapd. Okay, so after this session, I'm going to be spending time with 1.6.0 because you saw it crash. And that's not good to just install it and already have the crashes. I'm going to be going to release candidate 1 on a 32-bit. That's the first thing I'll do. And I'll tell you, I bet you anything I run the 32-bit, and I'm going to come up and I'm not going to have crashes left and right. Very common, the 64-bit, having issues. Okay? As far as T-Shark goes, the ring buffer issue, if you've been following Bugzilla, you'll know the ring buffer issue works. Ring buffer works fine with the 64 or with the 1.6 version. We don't have that problem, but we still have a problem with using display filters. We still have a problem with using display filters on live captures. We can't do that. If you want to do that, you've got to go back and back rev T-Shark. You can just copy tshark.exe from an earlier revision right over your existing T-Shark. Just replace the one you have with an older version and it'll run. So there's some gotchas there. Again, ask.wireshark.org is a great reference. All right, we are done with this session. Did everybody get their lab kits? If you didn't get a Laura's lab kit, Brenda's up here somewhere, and she will get those. And you guys have a great day. Have a lovely walk.